the fluorescent lines, standard circuits, etc. Now, there are differentiation between single-phase load and three-phase load. I separate them. Again, it serves a purpose. Right? If I have single-phase load, the first statement earlier I mentioned that I assume they are equally distributed. I mentioned in class that I may have single-phase load supplying all on one phase. Okay? If I have three-phase situations, right, it has to be three-phase because I did a three-phase aircon. But for the single-phase load, which is fluorescent light, socket outlet, and the standing fans, I can put them all in the same phase. Correct? I can put them all together in the same phase. But it is not a good design because if I put them all in the same phase, I overload on one circuit, whereas the other two phases are zero loaded. So what I do for three-phase circuit is I assume that they are equally balanced. So that means I assume that this load is distributed equally among all the three phases. Okay, so I assume that. That's why, right from the beginning, I make the assumptions. They are equally distributed across the three phases. Okay? I assume that they are doing that. So it is important that I separate the single-phase load and the three-phase load. For three-phase load, I don't need to do anything because if I have a three-phase motor, what happens is that my load is already balanced. This is my current. This current is already balanced. So if I have a motor, a three-phase current is already balanced. All right. I already draw the current from all the three phases. That's a three-phase load. Right. So for three-phase load, there's no need to rebalance anymore because it's already balanced. If I have a motor, the current is already automatically balanced. So I separate them into single-phase load and three-phase load. So single-phase load, I just use the 16 numbers of light times 2 times 36 times 1.8 because I need to allow for the discharge current. So I multiply by 1.8 and divide by 230. Okay? Don't divide by 400 because it's single-phase load. So that's why it's important that you separate them. This is single-phase load, so divide by 230, you get 33.8. Diversity factor for office is 30.42. Then the standard circuit for 30 amp socket outlet, so all same size, all of them are 30 amp. So I just choose any one. So for the largest one, there's no diversity, so I just multiply by 1. Whereas the remaining, I can apply diversity factor of 0.5. So 5 numbers remaining, multiply by 30 amp, and multiply by 0.5, I get 75. So standing phase, okay, I can calculate the wattage, very small, but then they are all off when the aircon is switched on. Okay, so it's 0 and 0. Right? The supply to the standing phase is equal to 0. So the total single phase load is equal to 135.42. The single phase load. And for three phase load, very simple. Three phase load, remember, when you want to find out what's the current for power, we always use this formula, power equal to √3 VI cosine phi. Okay? This formula is very useful. You use it very often. Okay? So you can find out the current demand for this pump. So 8,000 divided by √3 by 400, 0.8 and 0.5. Divided by the efficiency also, you get 17 amp. So for the first one, I apply 1. The second one, I apply 0.75. Okay. For aircon load, just to standardize it, I use table 4B, item 10. You refer to my notes. I use table 4B, item 10 for aircon load. So the total three-phase load is equal to 29.6. So the maximum demand will be equal to the equally distributed single phase load, right? 135.42, which is only on one single phase. So I assume they are equally distributed, I divide by 3. Then I add back the three-phase load, which is 29.6, I get 74.74 amps. And I allow 30% expansions, so I multiply by 1.3, I get 97.16. So the breaker has to be bigger than the current demand, higher than the current demand. So the breaker size is 100 amp triple pole. The second questions, I need to size the cable size, select cable size. is a three-phase load, 30 kilowatt, 400 volt, power factor 0.8, located in a separate building. Steel wire armor, multi-core PVC sheet copper conductor is being used. Again, if I were you, I'll highlight all this. The moment I see a question like this, I'll highlight this. Okay. Why I highlight this? Because I know that I'm going to use the table to find out what is the current capacity. And there are a number of cables there, from 4D1A all the way to I think 4J or whatever. So there are quite a number of tables there for PVC cable, single core, armor cable, XLPE cable, etc., etc. Okay. So in order not to confuse later on, I highlight it so that I will know that this is a steel wire armor multi-core PVC cable. The distance of this cable is 50 meters, and most of them is in underground. And for first sections is running together with two other similar circuits, and the temperature is 40 degrees C. So I want to find out what is the design current, and what is my circuit breaker size, and also the volt drop requirement. So again, I use the same formula. P is equal to 3 VI cosine phi, and find out what is my design current. So I can find out that it's equal to 54.1 amp. Okay. So again, we need to know the formula. Once I get the IB, I can choose IN. Because finally, IZ must be higher than equal to IN equal to higher than IB. So once I calculate IB, I will select IN, which is higher than IB. So if IB is equal to 54.1 amps, the IN that I choose is equal to 63 amps. Then write down, this is a reference method 11. Why reference method 11? Because this is on a cable tray. Cable tray, the installation reference method is 11. Okay. So from this reference method 11, I can go to table 4C1 and table 4B1 to find out what is the correction factor. Okay. Again, it's important to write down where you get the data from. Okay. No point just writing down the data where the market will not know where you get it from. Right? The danger is that if you choose wrongly, then you answer all wrong. And then when the market paper will not be able to see whether you really understand it. So for this kind of question, make sure that you write down where you get the answer from. Table 4C1 at 40 degrees C, it is PVC cable. Therefore, the ambient temperature correction factor is 0.87. So similarly, go to the table 4B1 for method 11. If the cables are touching each other, the grouping factor is 0.81. So then I use the formula IN over CA, CG, CI. CA is 0.87, CG 0.81, CI is equal to 1. Unless the question tells you that it is on the insulation materials. The question tells you the cable is installed in the insulation materials, then you apply a CI equal to 0.5. Okay? CI is either 1 or 0.5. Right? If it's on the insulation materials, you use 0.5. Otherwise, you just use 1. So I calculate the current 89 amp, then I go back to the table to choose 4D4A. Okay, why I go to 4D4A? Because this is an armor multi-core cable. Right? Some of you have gone to 4D1A. Right? 4D1A is for single-core PVC cables. That's why if you write down where you get the answer from, you also remind yourself, don't choose wrongly. Right? So if you write it down, it's multi-core armor cable. You go to 4D1A, you realize this is wrong. Right? So you have to go in 4D4A and choose the cable size, which is 25 meters squared.